Hello.
Hi, Steven. Hi.
Hey, good morning.
Hi, guys.
Hi, JB.
Hey, Alice. Hey, everyone. Hey, Christian.
Hey, since it's already 9:05, let's get started. Thanks, everyone, for joining the Catalog Community Sync. Since we have lots of topic today, as usual, let's get started. So first topic is carried over from the last sync, which is Alex Core 2. Please vote for the promoting signer endpoint to the main spec. So we have the PR and the voting thread open. Alex, do you want to add something more to this one?
No, that's pretty much it. Actually, I had two items, but one of them is already voted and merged, and then this one is currently being voted on. So yeah, just please go ahead and vote if you can.
Oh, thank you. Yeah, just encourage everyone to take a look and vote. The link are there.
I just had one comment on that. Taking a look at the PR, we've got all the implementation changes and the spec change all in one PR. Can we split the spec changes into a separate PR and just have the vote on that first, and then we can deal with the actual implementation? It kind of, convolutes thing if we're like not okay with some of the things, or we want to make changes to the implementation and we do want to approve the spec. So that would just be helpful to keep them separate.
Perfectly fine with that. Just one thing, if we merge the spec changes without the code changes, there will be a moment in time where the code base will be, slightly, okay.
Yeah, that's, that won't be the only thing that doesn't have an implementation at the moment, so. Okay.
That's fine. Okay.
Cool. Okay, so let's move to the next one, which is the granularity of referenced by context in low table cores. So this one is added by Christian, but I think Prashant, you also referenced there. So who want to give like a first introduction for this one?
Either of us can go. I mean, the thing is that we merged the PR already. So we started a dev thread and we built a consensus on that. So at this point, the granularity is like, even if it's a nested view, we'll give you the whole reference chain. And then you can decide at the catalog level based on the authorization and the security guarantees you have, how do you want to authorize against that? And as part of that effort itself, we ended up adding it into the load view, because a view can reference to another view, as well as in the load credentials endpoint, the same reference by query param. I already have the reference implementation ready. I have kept it in draft. I'll just keep it ready. Now, since the spec change is there, it will flow through all three endpoints. So all in all, this is settled. Thank you so much. Yeah. And thanks everyone for participating in this. It was a really nice discussion.
Yeah, that is great. And thanks, Prashant, for the summarization for this one. Okay, so I think then we can move to the final topic from the last sync, which is the UDF REST endpoint PR. Huaxin, do you want to give, actually is Huaxin here? Okay, so the PR is about add list and load function endpoints to OpenAPI spec. So since Huaxin is not here, probably we can like hold off this topic until she joined. And otherwise we can treat it as a general call for review for this PR and the REST spec discussion. Cool. Then let's come to the first new topics in this in today's sync, which is the credential refresh for Sage table creation. Melinda, I saw you have like a proposal and a spec change PR. Do you want to give us more context?
Sure. Yeah, so the main change that we are doing over here is for long-running C-test queries. So today, if we create a stage table, there is no way to refresh the credentials for the stage table, because from catalog's point of view, that endpoint does not exist. There's also a problem of what happens if there are two concurrent stage table requests, and how we can handle refresh for both of them. Now, one of them could eventually fail, but still we need to provide clients a way on how they can refresh credentials for the stage table creations. This has been brought up in community discussions a couple of times before. So the proposal is something that is along the line of how we added plan ID for scan planning and doing credential refresh for that. So I can walk through the proposal at a high level, but the idea is to have a session ID for the staging session, and the clients can use that session ID to refresh credential for their particular stage session. Yeah, go ahead, Ryan.
So the intent of the endpoint was to specifically not require state storage or basically a session ID and things like that for stage table creation. So I would definitely lean away from anything involving a session ID or things that require the service to keep state. We've gone through, I think this and with other things like server-side planning is a good example of where the initial proposal was, hey, we want to create server-side state and require some behavior around it. And we were able to change the design slightly to allow services to keep state or not keep state or do what they choose. So I would lean into that here. And I would probably say, what about similarly like reusing a plan ID or something like that? actually going and adding just the table, excuse me, the table UID of the staged table. That is just passing metadata back that is already existing. It allows the service to have a lot of flexibility in terms of how it tracks this state and what it does, and also like doesn't require a session concept.
Yeah, I think those are really good points, and we exactly started from there. Like in my first iteration, I started for table UUID, but that meant like in a service like Polaris, it needs to store the state, and this state has to be like a table UUID. The reason I switched to a staging session is like this could be a opaque token that the server can pass back to the client, and there is no state that the server has to maintain.
So I can't say, I can't speak specifically to the implementation on Polaris, but I would also extend this to say that like, the table UID is actually a contract between the catalog and whoever is staging that table. Like nobody else has access to that. It doesn't exist anywhere else. And it is a required field that needs to be produced. So that UID needs to be created by the catalog and handed back to the client as part of the stage create operation for the table metadata that's being returned. But this also has extended benefits in the fact that like right now, our refresh credential, if that table were to change underneath and you don't provide the table UID, like the catalog actually doesn't know that you're now getting a refresh token for the new table location as opposed to the old one that you were reading from that you started with. So I think there's actually a net benefit across both stage tables and the existing vended credential read path, because you can make sure that when the catalog is handing back credentials, it is to the corresponding table that was requested initially, which we don't validate currently. They can still validate that you have access to whatever the named reference is, but that may not correspond with what you were actually trying to read at the beginning.
Yeah, so like one thing I do want us to kind of evaluate is like the staging session is actually a superset of table UUID. Like if you think that table UUID is what makes sense for the catalog, you can still have your stable session as a table staging session as a table UUID. Like one reason is that today, like I was looking at I think Gravitino's implementation as well. So even that is kind of stateless, and it does not store the table UUID a priori. Like it let the commit of the stage table, and only at the commit of the stage table, the catalog persists the table UUID.
So I think I'm still pretty against adding session concepts and like these more complicated back and forths. However, it sounds like I have a general preference that is to reuse things that we're already using. So
Yep.
the table UUID seems like a good thing to reuse in a couple of cases. I hadn't thought about Dan's point where if you're refreshing a normal table credential, you could also pass the UUID. I think that is strong in that it doesn't require additional fields that have to be tracked and passed around and things like that. It sounds though that you're talking about a refresh token, right? So, I mean, should we be using a refresh token instead of, I mean, because what could happen is you pass, right, the token and a refresh token to the client, and then the client refreshes the credential using a refresh token.
Yep.
And that is more general because we could use that on more endpoints, right? To
Right.
Dan's point, we could use a refresh token as how you actually refresh the credential for a table, and other things, maybe the plan ID as well, like should have been a refresh token.
Yep.
Should we introduce the concept, or should we, I guess, lean on OAuth refresh tokens here rather than trying to roll our own?
That makes sense. So now, do we want a pre-existing mechanism for refresh token, or would it mean like just renaming the field as a standardized refresh token field?
Well, I think we need to look at this in context of how we manage credentials currently. So we have a storage credential construct. And if these are related to refreshing a storage credential, we need to figure out how does that fit into our current credential structure, and then how do we want to propagate that back to the catalog in the event that you are making a refresh call or something like that.
And how do we want to pass this into the OAuth APIs that we're taking advantage of?
This is not OAuth though. This
Exactly.
is OAuth.
Well, but okay.
Yeah.
Something similar.
Don't-
Like we want to lean on existing things is my point.
Prashant?
Oh, may I go?
Yeah, go ahead.
Okay, so this is one thing that one way to repurpose of the token. I think we were also internally discussing about it. Is that load table can return you the OAuth, new to OAuth token that it wants you to use now going forward. And that you can add claims. You can fit in the table but it's an explosion of your OAuth token. Now what happens is that because you got that OAuth token and this is the back and forth you're doing for authentication, you at a catalog layer know that, okay, this token, when you open that token, that's OAuth token, that it was issued for this table unit. That is something that we already have in the load table, that we can return a token as part of the load table response itself, which has the whole plumbing end to end. So the existing OAuth flow can work. So basically, essentially, when you load a table, you get a new token that has a claim for the table UU ID. And now that token, whenever it's passed through for any credential endpoint, you know that this token is or was for this table unit. So just saying that, okay, there is one way to achieve that. I'm not sure if that is the ideal way, because it's explosion of the OAuth token itself to add the stable unit as a claim or any other subject or something like that.
So these are two separate things, and we need to make sure that we keep separate the OAuth path and this storage credential path. And that's probably what Alex was going to say. So I'll just hand it over to Alex.
Absolutely. I can't say that I agree with the idea of reusing OAuth for that. I think we really should separate things, but I do like the idea of a refresh token. I just think that this refresh token should be something completely separate from OAuth that the catalog server owns entirely. Yeah.
Right. So then I think to make the feedback kind of concrete, we need to introduce a notion of storage credential refresh token that could be reused across different APIs. So I'll iterate on that feedback and then get back. I would like to say, like, are there any pre-existing things I know about plan ID that I should maybe align more closely so that like we can reuse or certain concepts from other places?
I would look just at the storage credential. I would not focus too much on the way that the scan plan API works as a solution to this, because there's a lot of kind of back and forth in that protocol for handling asynchronous operations and other things. So it's probably too complicated, and I don't want to extend off of that. So I would just look at the storage credential and see if we can fit a refresh concept into that. And then, like, how do we plumb that into the request? Like right now, I think refresh is just a get operation. So it would probably have to be a query parameter or something like that, unless we want to alternatively expose a post that would allow us to send more information to the catalog on a credential refresh.
Got it. Yeah, that sounds good. Go ahead, Prashant.
Do we want to like work on expiry of that token, or like just want to be opaque and, okay, yeah, we issued you this, now you can do that, and rest all is on catalog source on how they want to invalidate that, because the storage credentials are tied to the grants. They are vended according to the grants defined in catalog. One of the
But I
things
think they already have expiry. We're
Okay.
already using the storage credential expiry, and that's the expiry of the actual So this is the problem. Is like we have the expiry of the actual credential that we're
Yeah.
provided.
Yes.
Then you have the question of, well, what's the expiry now of this like refresh
Exactly.
token, and how does
Exactly.
that need to be handled? It always just gets more complicated as you pull on that thread.
So
So
this is, I think, where it is good to at least understand what OAuth has done, right? Like we don't want to mix S3 or other credentials into the OAuth path. I agree with that. That was my bad. But like for how refresh tokens work, it seems like it should be a very similar thing. And so we can look to OAuth for prior art.
Yep, sounds good.
And
Thanks.
it might be that we decide to switch around, how some of these other things work and make, Plan ID legacy. But I agree with Dan that let's look into what this should look like as a general refresh strategy, and then we can revisit it later, or revisit the existing refreshes later.
Makes sense. Yeah, that makes sense. Any other comments, folks? Okay, good. Thanks.
Yeah, thanks, Melinda, for the proposal, and thanks, guys, for the great discussion on this one. Since we have passed for the next step, so let's move to the next topic, which is batch load endpoints. Stephen, do you want to give us an?
Yeah, so last time we briefly discussed this a little bit. I think the motivation use case can fall into two buckets. First one is catalog replication, which tends to have large batch. I think for that, we get feedback is, hey, if we have the event endpoint, we need the batch load endpoint, right? So if the event endpoint provides strong guarantee, that definitely is more efficient solution for catalog replication. Then there's also a question, hey, what's the SLO for the catalog replication? I think last time I heard something like 24 hours. I think in practice, I think the SLO for catalog replication typically much lower than 24, maybe 30 minutes, or maybe even 10 minutes. So the SLO is actually much lower than the 24 hours we talked about last time. So that means that if the event endpoint cannot provide strong guarantee, it's kind of hard to use that for as a efficient replication. Yeah, right.
Sorry, I didn't mean to interrupt. So if you're
No,
still
go ahead.
going,
Yeah, we just talk about the first one, then we can focus on, we can move on to the next.
I think it is important to separate these two, because a multi-table or multi-object load endpoint looks very different than a bulk endpoint. A bulk endpoint is going to be like, hey, give me all the objects in a thing and paginate them and so on. Whereas a multi-object load endpoint is going to do, say, here's a list of things to load. Here is a list of those things back. And if you don't get all of them, you call it again, right? Like, so it's a very different endpoint. I think we do need to talk about the guarantees of the events endpoint and how we can build on top of that, because the events endpoint really should be what you're using. I think the trouble is, to your point, if you can't trust a catalog to produce the proper events, then like the guarantees you can make about that federation are lower. And I don't like the idea of requiring catalogs to produce, the exact stream of events, because we've talked about how difficult it is to guarantee that durability. It's essentially a two-phase commit for basically, all catalog operations. And so guaranteeing durability is very, very difficult unless you're going to the trouble of, reading the bin log off of your database, things like that. I don't think, though, that means we should give up on the events endpoint, though. Right? Like some catalogs will be that sophisticated and be able to guarantee within some, I guess, I don't know if it's an SLA or an SLO, but like some catalogs will be able to make those guarantees. And I think that replication depends more on the producing catalog than the consuming catalog. And I think that when you set up these relationships, you have to say, essentially, like, this depends, you know, our guarantees depend on the guarantees of the producing catalog. This is like when you sign an SLA for, you know, running a SaaS service, you say, you know what, our guarantees kind of depend on AWS or Azure being up, right? Like, we can't guarantee you higher uptimes than the cloud providers that we all run on. And so, like, I see this as an area where you can provide guarantees, but those guarantees must depend and account for the, you know, the issues or guarantees of the producing catalog. I would really hate to say, like, because not all catalogs are going to be 100% reliable here, that we have to, we just won't use this endpoint at all.
Yeah, I think I definitely agree that some catalog they may implement the strong guarantee and some may not. And yes, the replication service will depend on what the source catalog can provide. But let's say if a replication service is working with the source catalog that doesn't provide strong guarantee but provide the bulk load endpoint, then the replication service potentially can leverage the bulk load endpoint to implement the replication, which will be less efficient compared to events endpoint for sure, but it will be a lot more efficient compared to single load endpoint for that replication.
That gets to, what are our goals right now? Are our goals to build these catalogs so that they can accept data from any endpoint, or are we trying to, you know, build replication from a small set of, you know, mostly trusted endpoints? This goes back to, like, the trusted versus untrusted sort of argument, where in connecting catalogs to external services, we generally make it up to administrators whether they are okay with what those external engines or external catalogs are going to do. In the security case, we say, you know, you need, the administrator connecting whatever engine to this catalog, need to know whether it's going to be a trusted engine. I think this is the same sort of thing where you're configuring a catalog to mirror another. Like, you need to know what the guarantees are and you know, switch to the, you know, choose your mode. But when it comes to, like, what we need to do right now, like, I would say leaning into the events endpoint is probably better for these systems. Now, I think that's up for debate, because it could be that a load endpoint, right, scraping a catalog is the lowest common denominator, and therefore you get reliable behavior over a longer time period. That is, like, you might scrape once an hour, but scraping gets you the data that you want. Events gets you a dependency on the events of the producing catalog, but you have, you know, a poll operation that gives you much faster updates. So which one do we want to pursue right now? I think that's probably the better question.
Yeah, just quickly, I think, as you mentioned earlier, to support the strong guarantee is actually pretty complicated, right? Require definitely a redesign of a persistent layer. You may need to do a multi-table transaction to commit the change log and then also the table change in one transaction, something like that. So, yeah,
to
not
guarantee 100%.
Right.
But there are, you know, 99, you could probably get to 3 or 4 nines worth of reliability fairly easily.
Yeah, but for like a replication service to work to provide SLO, they actually want to achieve a kind of 100%, because hey, for all 100% the catalog change, we're going to replicate that within, let's say, 30 minutes or whatever target we're trying to set up. So yeah, if we don't kind of provide those kind of strong guarantee in the replication service, it's kind of hard to rely on event endpoint that's not guaranteed, not 100% guaranteed. Yeah, and also batch load endpoint will be a lot easier for the source catalog to implement because it just there's no change in the persistence there. It just kind of is relatively straightforward. Yeah, I'll hand over to Dan. Yeah.
There, across the use cases, there's actually a little bit of a semantic difference between how we would use these anyway. So like the bulk load, depending on like how you're identifying what you want to load through listing or some other mechanism, is go get these things. But when you look at it through the lens of the other use cases, it's actually not. It's like we want to unravel the dependency chain for query optimization. And so you would potentially be loading more than you're asking for. And those are two different kind of semantic behaviors of like how we want to interact with a bulk load. So I'm not sure that they're actually the same thing.
Well, in some sense, they are same. For example, if you look at the material view, the freshness evaluation, right? If you have source table state, you know that this is a table you want to evaluate. Hey, that's same thing to like replication. I know I have this table I want to check if anything change. For sometimes they are similar, but yeah.
But again, like with the materialized view, I may want the view definition, I want the storage table definition, and I want the definitions of all the source tables so that I can do my MV evaluation. But if I'm just doing like a catalog federation approach, like I don't necessarily need all that same information.
Well, for the universal load endpoint, I have separate discussion with Republican. Yeah, that's related, but it's a little bit independent for the universal load endpoint. Yeah.
Russell.
So I was trying to think about this in terms of use cases. We had some internal discussions about this too. And I think it comes down to, I mean, I think our goal in all of this has been to ease the load on the catalog that's being federated to. And in order to do that, we need to either trust what's in the federated catalog or we have to keep calling the final endpoint over and over. And with the weak guarantee, if we know that, we still can get that behavior, but we still end up calling the end catalog all the time, right? We have to always do a load table. We can do it with an E tag. But basically every client read to the federation center has to also do a read out to its target to see whether or not things have changed. If we have an unreliable thing and we don't want there to be a gap. I think that might be an okay model, but that's a lot of traffic. But I think that's where we are if we have no guarantee on the events. Like that's the behavior I think we want to provide, is that it's never wrong. But that means we still have this outgoing traffic.
I think my take here, which is probably not what customers are demanding, to be fair, is that you're not going to be able to make 100% guarantees. And I would much rather say we're going to have a guarantee that depends on the events coming from the producing system. And we will, do a full refresh in the event that something didn't happen, like on a very infrequent basis. If you and this is where I think we need to view this as a trade-off. How often can I go scrape the remote catalog, right? Like it's in minutes, in my opinion. It's in the minutes. Like if you're scraping us every, say Unity catalog every 10 seconds, like we're going to throttle the crap out of you and you're not going to make your guarantee. So like there's, how many minutes between full catalog scrapes, or do you want the events endpoint that may in, 1 in 10,000 or 1 in a million drop for some period of time, right? And so like, I think the events endpoint is still the better call. Can we do something where we detect that these events are gone and you can do a full load or something? Like, is there a compromise here? Because I don't see full scraping and this as like a viable strategy to make guarantees, because like users want updates within seconds and 100% reliability. And I just don't see those things as possible in a catalog federation case unless you do a pass-through.
Yeah, so usually users don't need like a seconds level latency kind of target. Most likely less minutes, like 10, 30, 60 minutes, but definitely much lower than 24 hours for sure. And usually would like that to be 100%. Hey, when you said that, so otherwise they don't know, okay, if I can rely on that federated catalog or not. That can be a big problem for users.
Yes.
Yeah, I just want to add one maybe not so big use case that is AI workloads. Sometimes when the language model try to grab all these tables, metadata, potentially for all the table, like for example, just a one small example about 100 table under one namespace. The current loaded table response where it's relatively slow, right? For 100 table. So this is a good number actually, because it have to do 100 times, and a lot of times the language model just give up and say, okay, I cannot do that. Batch loading provide a much more efficient way to load all these things together. Of course, you still have to set the limits. Say, okay, you cannot go up to say 200 or 1,000 table.
I think we are finding use cases to build what we want rather than like thinking through the problem at hand, right? Like I do get that there is a multi-table load use case where you want to resolve all the identifiers and bulk load those for a query at the same time, as well as dependencies. So if one of those is a view, you want to get tables referenced by that view at the same time. Like a single round trip to the catalog would undoubtedly be better for queries. But I don't think that we're talking about that necessarily, or this AI use case, because we have users coming to us and saying like, hey, we have AI use cases. I think we're talking about it because we have catalog federation. So that's why I want to focus on the catalog federation, because like, yes, there are other uses of these endpoints, and maybe we'll get to those, and like, I'm not opposed to adding a bulk or multi-table load endpoint. It's just that I want to make sure that we are meeting users' needs, and that like the endpoint that we designed for this catalog federation scenario is something that we can actually use.
I agree with catalog federation, because even though you use bulk loading, still sometimes you don't have the 100% guarantee, and due to like time step drift, like when you have multiple query times, it's not necessarily complete align with each other, and path through plus events may be still a good way. One of the concerns from my side for events is you still have to query the event endpoints from time to time, right? It's quite similar if we consider bulk loading with e-tags. You get less data than load a whole metadata of all tables. The event endpoints, you still have to scrape whole events up to the last checkpoint and load them and do the processing every certain minutes. Depends on what kind of guarantee you want to provide to your users. It's still a kind of bulk loading for events. I mean, even it's one guarantee provided by the catalog.
I mean, I guess what I'm saying is we need to, I think we clearly need events, or like, if you actually want to not be up to 30 minutes out of date, say, we need the events endpoint. We need to use the events endpoint. We probably also need something to detect when we are, out of date. And that might not even be a, bulk load all table data endpoint. Like maybe it is just here's an identifier and the current E tag. And if you don't have that E tag, like I don't have a problem with that, but I guess I'm pushing back on this idea, because if we are saying we're always going to be correct, you're compromising that somehow, either
Well,
in time or in you know, guarantees on every single object. And so how do we make this reliable without, you know, scraping every 30 seconds?
So
Go, Russell. You know,
you actually raised your hand and I didn't.
You were already talking though.
I was just going to say, I mean, like, that's kind of our current plan, is to add a buffer in there and basically say per table, per request. Per table, we are not going to request a refresh more than like a minute or so. So regardless of how many reads happen against the Federation catalog, we'll only do 1 per minute to the upstream catalog to get current state, just in case it's changed. So you still get a huge drawdown. You get a 1 minute buffer, and we're going to use the normal API. So that's a huge, smaller amount of requests, but it's still non-zero. And I'm wondering if that's the kind of thing other catalogs want to be able to support.
I mean, is that sort of thing a reasonable alternative though, where you consume events and then, like, you know, if you haven't queried this table in a while, you'll go check the E tag?
I think so. I mean, I think that works for us. At least in our last discussion, we were kind of okay with that as a plan. The question is for other catalogs which have had load issues, is that okay? If we take it down, this should take it down a couple of orders of magnitude in the number of requests you get, but it's still going to be proportional to the number of tables that are being.
Russell, it almost sounds like the
through.
use case that you're talking about, though, doesn't align with the bulk load approach, because
I'm not saying bulk load. I'm saying normal load table for each of these.
The idea being that, like, you're doing kind of a you know, debouncing of hits to the backend catalog. So hey, if somebody's hitting me very quickly, I'm gonna debounce for some amount of time before I go and check the upstream catalog. The likelihood that you would gather like multiple requests or anything like that, you know, doesn't happen in that scenario. And then your out of sync nature across the entire catalog space, other than listing potentially, like if you're also federating listing, which would probably be happening on some sort of cycle just to identify what's back there, all of that is almost just in time kind of federation. And that doesn't necessarily even require the events endpoint, unless you want to augment it with the events endpoint to update more frequently and say, hey, if we're getting the information from the events endpoint, I may not have to go hit, or maybe I want to hit so that when my next request comes in, I'm already up to date and I don't have to do a debounce that would like add some latency or something like that.
Yeah, I mean, the goal is that you do an E tag load on most of these hits too, right? Even after debouncing, you're mostly doing an E tag. So you want to do events so that you aren't actually having to rely on it, that you have the right information and the response comes back very quickly. You don't have to update anything.
Yeah. So
I agree.
Is that the intent to like drive it, like the E tag hit, is that to drive down the latency, or would you still potentially have like this debounce of like, hey, if it's within 5 minutes, I'm not even going to go hit the E tag because, you know, and then after that point, I'll hit the E tag and load only if necessary.
Yeah.
Yeah.
So basically, we're still not trusting the events endpoint entirely. We're still going to check constantly, but we're not going to check as frequently. So it won't be like a one-to-one of the requests coming into the federated catalog, and it won't be a batch hit of every single table on a frequency. It'll just be what tables are actually being accessed.
But that model is also like very different from the, hey, I'm going to just like bulk scrape, other than the initial propagation of things. But even that, like, it's mostly listing, right? Because, you know, all you really need is the listing. And, you know, I don't know if that means that, hey, the right answer for catalog federation is an inventory endpoint or something to give you that listing, you know, more efficiently than going and hitting every, you know, every schema. But maybe it's fine. Like, what we have to do multiple hits for the schema traversal right now, but other than that, like, it feels like we have everything necessary for reasonable federation, and like bulk to support federation almost seems like a bit of an anti-pattern.
Yeah, I think I'm coming on board to this idea. I think I want to do this other model instead. If we're not going to do a bulk endpoint, so the assumption is that a bulk endpoint might be easier for a catalog to handle than, again, still passing through requests for every single table, possibly on every minute. You know, if I have 10,000 tables and all of them are accessed every 5 seconds or something like that, I'll take that down from, why am I doing math in my head? 12 per table to 1 per table per minute. So a lot less requests than a full pass through. Hopefully their ETAG passes, so this is also a fast response. But theoretically, is that better than one single batch request every minute that just says, I need everything again? So the question is,
You still don't know what's going to be accessed, and like, you know, for catalogs that have 100,000 tables in them, do I just like constantly batch poll against that catalog? I'll just be on a loop forever.
This is true, but if I am accessing all of those 100,000 tables, I'm gonna make 100,000 requests.
But no, that's not true, because the events endpoint sends you when this table was updated. So you would know, if I got an event for this table that was updated in the last 5 minutes, I don't actually need to go request it from the other catalog. So the events endpoint actually says, like, okay, we're basically going to have a way to detect when my state is up to date for changing tables, and we're okay.
Only if the tables are continually updated. After
Only
5 minutes, if my table is not changed again, I now have to check still every minute after that to make sure I didn't miss an event.
I mean, so
still less requests.
I should say, Talit, thank you for being patient. You know, what if you have a small number of tables that you just place, like, hey, it's unchanged state events into events, right? Like, hey, this is still the state of this table. That I think would be better than a like bulk load endpoint. And it's not that I am, again, I'm not against the bulk load endpoint. I just want to solve this problem in a reliable way that doesn't require full scrapes all the time. And so hopefully we can figure out a way. And I'll pass it to Talit. Thank you for waiting. Sorry.
I was going to suggest that, you know, the events endpoint is just a call, but why we are not thinking about, we rely on the GCS, why we don't rely on the Kafka? Kafka is de facto standard now between the cloud providers. All of the cloud providers is providing the stream or Kinesis, you know, for AWS, even though they have the Kafka. Events we can publish on Kafka, then the federation, you know, whatever this catalog is federate, they can publish on the events on Kafka, then the other catalogs can listen that. This is what we are discussing. It will not scale, right? We are just thinking about the 2 catalogs. If we are doing the federation with the 10 catalogs, and that the 10 federated catalogs has to scale the request across the other catalogs also. So this is kind of brutal in my view. You know, for the scale, maybe we should think like, you know, the streaming in a fashion then each catalogs can read from the Kafka, and we can extend the events endpoint kind of like, this is a streaming endpoint. If you want to federate a catalog, just, you know, to listen to this endpoint, it can return like credential vending. It can return the, you know, the Kafka bootstrap servers and whatever authentication. Then the clients start listening to that endpoint.
I think Christian is here. Christian, do you want to answer that? If not, others can also come in.
Yeah, sorry, I was just typing a response. Yeah, so I guess, so I agree that, of course, I mean, having a pub subsystem is something that scales a little bit better. But nevertheless, I think not requiring an additional component is very, very helpful. And I think catalogs are like free to just use. And I think the events specification is probably really good for that, to use it as a base to design these events that are then sent to Nuts or Kafka or wherever. But I don't think it actually just basically defining events without any endpoint solves the problem at hand. So yeah, that's my take.
I just want to jump in as a follow-up response question. Yes, events endpoint is good, but actually we are trying to design a Kafka kind of things, because then client has to call the events endpoint each time, which means that it has to scale also too. And the Kafka is already solved that issue if we can introduce that current event endpoint and next to the streaming endpoint for events, same events, then we don't need to reinvent the things. And also we rely on Kubernetes, S3 or GCS, so many things, right? Then this is just additional component.
Yeah, I think my point on that is each individual catalog service provider can definitely do that. Although for the similar situation for the events, if they want to provide a guarantee, they still have to do what Ryan said, the two-phase commit, which is kind of a database level CDC to the Kafka, and then all these consumer can consume that with a guarantee. By saying that, the individual catalog provider can definitely do that. I think for even if you look at the products in the markets, like HMS providers provide these event listener, you can definitely hook up the event listener and push them into the Kafka, and all these downstream can do that. So I believe that the point we discuss here is we try to provide open standard for that, which in this framework that you can actually have these interoperability cross catalog, not to rely on each individual implementations. That is important for this forum. I think that's what we're doing here. Try to have these events. We have this. The open standard has been formed, which is either events or bulk loading we discussed about. And in that case, for example, the guru can say, okay, I provide the complete IRC compatible, or players can provide IRC compatible. The other catalogs can be free to use them without hook to each individual, each different systems for that. Yeah, that's it.
I just want to quickly echo one of the things that Christian said earlier, because I think with the events endpoint and the polling model by the client can easily check what last bookmark I meant. So it's actually very easy for the client to integrate. So that's one of the benefits I see from event compared to the Kafka and all the other problem you need to book through. I do think the event endpoint is pretty easy to work with. That's it. I hand over to Ryan.
Yeah, I thank you, Yufei, for making the comment about the two-phase commit. So like any of these events do need to be made durable in Kafka and durable in the actual store. And yeah, you kind of want your Kafka to follow your database. And so that's where you get into like your CDC and bin log reads and stuff like that. So that's a hard problem. Again, like in general, at Tabular, we had this mirroring stuff implemented, and like it didn't have 100% guarantee, but it was almost always correct. We do need to think about how to do those guarantees. I actually really like the idea of using the events endpoint to stay as up to date as possible very quickly, because like even the receiving catalog doesn't want to get 1,000 updates. It has to apply to its database all at once. So using that as much as possible and leaning on the events endpoint, I think is good. Then the guarantees are really like, well, how long has it been since I have refreshed this table? So if you get a query in that says, load this table, and you haven't loaded it, or you haven't seen a change in the last 15 minutes, you don't need to do anything because you're within your polling interval. And if you're outside of 30 minutes, at 35 minutes, hitting the catalog to load that table once, I think is probably a reasonable design. I'd like that better than relying on the polling on the bulk endpoint. Now, I would say a 24-hour, hey, pull it all bulk, again, I think a bulk endpoint can make sense, or at least a bulk endpoint that looks like maybe a information schema table with an E tag, some things like that to help us, design for this pull everything use case. I really do think that that's valuable, but, what do we think that the mostly using events and then making guarantees based off of, single table loads when necessary? Do we think that that is a viable option? Because I think that that minimizes complexity from where we are today. We rely primarily on events and have up-to-date things. Then we can turn off the actual table loads depending on the guarantees of the upstream catalog, which I think is good, right? If you have, say, Horizon reliably producing this stream of events, then you don't need to do the query time loads. And this seems like a very reasonable solution to me, and takes the pressure off of adding a bunch of bulk load endpoints, even though we may want to add those for, total synchronization, bootstrapping, AI use cases later. Does that sound like a path forward, or am I crazy?
Yeah, I think the catalog application, I think the just-in-time refresh and the event endpoints, I think it seems to be a good, reasonable solution. Yeah, but we haven't talked about the batch load endpoint. Like I want to talk about.
Well, yeah, that but I think Dan said it earlier. I think that I would call this a multi-table load endpoint, because the behavior is probably that the idea, I think, is I want to resolve all the table references in my query, or sorry, relations in my query, and load them from the catalog in a single call. And to me, that means the catalog has very different behavior. It should actually go load an object no matter what it is, right? This is the unified view table endpoint. I think it should also load dependencies. So if it loads a view, view V that references tables A and B, I want it to send back V, A, and B, so that when I then resolve the view metadata, or at least be able to send back all three.
Yeah, so
that endpoint is slightly different.
Yeah, a universal load endpoint we have discussed in multiple different contexts. It's related, but it also can be because it can be applied to both single load endpoint and batch load endpoint. For sure.
Yeah, just to add more use cases for the batch load endpoint, one was when the engines do analysis, they figure out which entities they want to load. And we were in the prior experience, we're seeing that analysis on one by one table entities, it was taking a lot of time. So we just grouped them into one batch load call. And it is when using Glue with the EMR. We were able to gain performance gains as well. So it can be taken as, okay, I want to do analysis. I already know that these entities are part of my query plan. I want to unload them to find the schema. Those things are also, in addition to the materialized view use case that we're talking of, can be useful for bulk loading of these entities in one shot. So just one use case more that I want to bring it up on the load.
I agree with that. I think it's kind of an interesting idea to say the listing endpoints maybe provide E tags so that you can identify what you need to load, and then you use this sort of bulk load endpoint with maybe dependencies turned off to load just a handful of objects. I think that there are some interesting designs here to reuse.
Just last minute, I create the PR for the UUID change on namespace. Could you review that? Thank you, Edward, for the reviewing.
So yeah, I just want, so since we haven't got enough time to run over all the topics, just a quick call before we end that we have the remote scan planning discussion in the PR, and we also have the namespace view at Iceberg change PR and implementation. And we also have another discussion about introducing operation type in low table operation. So this topic will be carried over to the next meeting, but please do not hesitate to discuss them in the middle, because it's 3 weeks later. I will share the recording shortly after this meeting ends. Thanks everyone for joining, and see you all in the next 3 weeks.
Thank you.